Welcome to All This Math. This is Professor Parker, and I'm here with my man, the ancestor, the late Patrice Lumumba on my shirt, and I'm ready to multiply some mixed numbers. All right? Now let's get to it. So I got two examples up here. One is 2 1/4 times 1 1/2. My second example is 3 4/5 times 2 6/7. So what does this really mean? This means that, this number is not one thing. It's mixed, right? It's got a whole number part and it's got a fraction part. Just as this number has a whole number part and a fraction part. So this number is more than 2, but less than 3. This number is more than 1, but less than 2, 1 1/2. This number over here is more than 3. It's almost 4, but not quite. More than 3, but less than 4. This one is more than 2 and less than 3. So when we're multiplying, the first thing we want to do is we want to convert our mixed numbers into fractions. We want to convert our mixed numbers into fractions. All right? Now, how do you do that? This is how you do that. You convert the mixed numbers into fractions by taking the whole number. You start with the whole number. This 2. You multiply it by the denominator, the number at the bottom of the fraction, right? So you do 2 times 4, right? You get that product. You know 2 times 4 is 8 because you know your multiplication facts. 2 times 4 is 8. Then you take that 8 and you add it to the 1. 8 plus 1 gives you 9. Now, in your fraction, that 9 is going to be your numerator. That 9 is going to be your numerator, right? Then you should be wondering, well, what's my denominator going to be? When you convert a mixed number to a fraction, the denominator stays the same. The denominator from the fraction part of the mixed number is going to still be the same. It's going to be the same. It's going to be the denominator in your fraction. So this is going to be 9/4. All right. So that's how you convert a mixed number to a fraction. And that's our first step. You got to convert the mixed numbers into fractions. Then you put your multiplication sign. And we do the same thing right here. We do the 1 times the 2, which gives me a product of 2. And then we do 2 plus 1. So 1 times 2 is 2. And then I do 2 plus 1, which is 3. And I keep the same denominator. I got 3 for my numerator, but I keep the same denominator. I got 3 halves. All right? Now I'm ready to multiply, right? Sometimes I could do something called cross-canceling. I can cross-cancel if I look at the diagonal, the numbers that are diagonal from each other, and I see numbers that have a greatest common factor besides 1. That's not 1, right? 4 and 3 have a greatest common factor of 1, so I can't cross-cancel those. 9 and 2 have a greatest common factor of 1, so I can't cross-cancel those. So I got to just multiply the old-fashioned way. I got to multiply straight across from left to right, numerator times numerator, denominator times denominator. And that's cool too. So I do 9 times 3, and I know my multiplication facts. Because I know my multiplication facts, because I study my multiplication table, and I practice, filling out blank multiplication tables, and that's what I get into, right? And that's what you should do too, if you haven't already. I know that 9 times 3 is 27. Off the top, I know it's 27. Then I do the same thing with the denominators. I do 4 times 2. 4 times 2, I know my multiplication facts. I know that's 8. So 4 times 2 is 8. Now, this is the product, right? It's not the final answer. Only reason it's not the final answer is because if the original problem was given to us in mixed number format, then our answer should be given back in mixed number format, right? We should give it back the way it was given to us, okay? So these original numbers were mixed numbers. Our answer should be a mixed number. So now I'm going to show you how to convert an improper fraction. I should have told you that earlier. This is called an improper fraction because the numerator is bigger than the denominator, and that looks weird, right? It kind of defies the concept of a fraction. You know what I mean? So I'm going to convert this improper fraction into a mixed number. Now, this is how you do this. I like to use a method. We're basically using division. That's really all we're doing. And we're figuring out what our remainder is, right? But I like to use a method. I like to think of it in terms of finding seats, right? Groups of people trying to find seats. You know what I'm saying? You ever go somewhere with a group of people and it's a lot of y'all, and y'all are trying to make sure that everybody gets a seat and y'all all want to sit together, right? So imagine it's 8 of y'all, right? The bottom number tells you how many people are in the group, right? And let's say it's a few groups of y'all, right? It's a bunch of y'all, right? But y'all are split up into groups of 8. The bottom number tells you how many people would be in each group if you're using this method that I'm talking about now. The bottom number tells you how many people would be in each group. The top number, or the numerator, tells you how many seats there are in that place you're going to. Whether it's a restaurant, whether it's a cafeteria, whether it's, I don't know, auditorium, whatever, you know, little small, like little area where somebody might be playing some music or something. I don't know. It don't matter, right? Use your imagination. The question is, how many groups of 8 can fit into those 27 seats? Now, we're talking about whole groups. We're not talking about a piece of a group, but whole groups only, right? I know that 8 people is in one group, so at least one group can fit. 2 groups will be 16 people. That's less than 27, so at least two groups can fit 2. What about 3 groups, though? That's 8 times 3. That's 24. So 3 groups can fit, because remember, the top number is how many chairs there are. The bottom number is how many people are in one group. So think of it that way. The bottom number is how many people are in one group. The top number is how many chairs are available. So you can visualize this in terms of a real life situation, right? So I know 3 groups can fit into 27. What about 4 groups? 4 groups, that would be 4 times 8. That's 32 people. Chill. It's only 27 chairs, bro. 4 groups are not fitting. 4 groups will not fit, right? So that tells us that 3 groups will fit. The number of groups that will fit, that's your whole number. That's your whole number. So 27 over 8 is going to be equal to 3 and a fraction with it. Now, how do you get the numbers from the fraction, right? The numerator is the number of chairs that are left empty. So remember, we said there are 3 groups, right? 3 groups can fit. So that means that 3 times 8, that's 24. That's 24 people. That's 24 people, right? So if 24 people sit down and it's 27 chairs, how many chairs are still empty? 3. Exactly. Because 27 minus 24 is 3. So that's your numerator. 3 is your numerator. Now, just like sorry about that. Motion lights. I wasn't moving around enough. All right. So anyway, I'm back. Just like with when you're converting a mixed number into a fraction form, we keep the same denominator. We do the same thing when we're converting back in the other direction from a fraction to a mixed number. So now I got my 8 right there. So that means that 2 1/4 times 1 1/2 is equal to 3 3/8. 3 3/8, which is more than 3, but less than 4, right? This number is between, this value, I should say, is between 3 and 4. All right? That's how we do our first example. Okay? Now, we're going to do the same thing with this one over here, the second example. The second example, we're going to convert 3 4/5 to a fraction, right? Let me move down here, all right? Make more space. So, 3 times 5, that gives me 15. 15 plus 4 gives me 19. 19 is my numerator. 19 is my numerator. I keep the 5 as my denominator. Then I'm going to do the same thing with 2 6/7. I do 2 times 7, which is 14. Then I add the 6 that's on top. 2 times 7 is 14. Add the 6 that's on top, that gives me 20. Now I keep the denominator of 7. So now my fractions are 19/5 times 27. Now, with this one, I can cross cancel. And I always check to see if I can cross cancel. And with this one, I can cross cancel. Not with 19 and 7, because their greatest common factor is a 1. 1 is the biggest number that divides evenly into both of those, or multiplies evenly into both of those, I should say. But with 5 and 20, 5 is the greatest common factor of 5 and 20, because 5 times 1 is 5, and 5 times 4 is 20. So 5 is the biggest number that multiplies evenly into 5 and 20. So once I know my greatest common factor, what I do to cross cancel is I divide each number by the greatest common factor. Again, I divide each number by the greatest common factor. Each of these two numbers, that is. and not the 19 and the 7, just the 5 and the 20. So I do 5 divided by 5. And 5 divided by 5 is 1, because anything divided by itself equals 1. Anything. It don't matter what the numbers are. No matter how big, how small. They could be positives, negatives. It don't matter. Anything divided by itself equals 1. So 5 divided by 5 is 1. And 20 divided by 5. What does 20 divided by 5 equal? 20 divided by 5 is equal to 4. So that's why this changes into a 4. So now I do my multiplication. And the benefit of cross canceling is now I'm dealing with smaller numbers. I want to keep my numbers as small as possible, because the larger my numbers are, the more complex the math is. The more complex the math is, the more likely there is a chance of me making a mistake. And I want to minimize the possibility of mistakes at all costs. So now I do 19 times 4. And if you don't know that off the top of your head, that's cool. You can get a calculator, or you can do the manual math on paper. But 19 times 4 is 76, right? Your calculator will tell you that too, all right? Because you could think of it like this. You could split the 19 up into 10 plus 9. 10 times 4 is 40, right? Means you got $40 in one hand. 9 times 4 is 36. You got $36 in the other hand. Put all your money together. 40 plus 36, that's $76. 19 times 4 is 76. Then in your denominators, you got 1 times 7. That's easy to do. 76 over 7. All right? So now, here's the thing. The original problem was given to us in the form of mixed numbers. But now we have an answer that's in a fraction form. And it's improper. It's an improper fraction because the numerator is bigger than the denominator. We don't want that. We don't want to go out like that. We can't end the problem in that manner. So what we're going to do is the same thing we did in the first example. We're going to, play the chair game, right? We got groups of 7, and we got 76 chairs. Groups of 7, and there's 76 chairs. So I'm thinking like, okay, well, what if I just took a guess and said, okay, well, what's 7 times 10? What if it's 10 groups, right? That would be 70 people, because 7 times 10 is 70. And there's 76 chairs. So I'm cool. I could do that. But what about 11? What if it was 11 groups? I know my multiplication facts. 7 times 11 is 77. 77 people? Nah, they're not fitting in 76 chairs. It's only 76 chairs. So that means that 10 groups can fit comfortably. Only 10 groups. So that means that 10 is my whole number. 10 is my whole number. Now, remember what we talked about in terms of how you find the numerator? The numerator is the number of chairs that are left empty. So if 70 people sit down and there are 76 chairs, all you have to do is subtraction. You do 76 minus 70. 76 minus 70 is 6. So that's your numerator. And again, the denominator does not change. The denominator does not change. So this is our final answer. 10 and 6/7. So we got 10 and 6/7 for our second example. For our first example, we had 3 and 3/8. All right? And that, my good people, is how you multiply mixed numbers. All right? That's how you multiply mixed numbers. That's how you convert from an improper fraction to a mixed number. That's how you can convert from a mixed number back to an improper fraction. We did a lot in these two examples. All right? If you haven't subscribed to the page already, please subscribe. If you feel like you learned something from this video, like the video. Also hit the notification button if you haven't already. So whenever I come up with new content, you'll be notified. All right? And always remember, there's all this math all around you. Peace.